Hi, this is Thomas from Apex Game Tools. In this video we're going to look at how you issue path requests, specifically some of the changes that have been made between previous versions and Apex Path 2.0. So, well, we'll jump straight into the code in just a sec. As you can see, we have a pretty simple scene with the unit, and then we have a target up here that we want to move towards. So we basically want to request a path from our current position to this target. So there are a few ways to do this, and we'll look at each one of them in turn. Now the first thing to do is to get hold of the unit through its unit facade. So we get a hold of that here. We then define a callback which will be called once our result is ready to use, so that we can actually use it for, well, normally moving the unit, which is exactly what this one does. So in this callback we check the status of the result. This is just a very simple check. It doesn't really process any error conditions. It will just check if it is complete, which is the success condition. If it's some other condition, it will just return. So nothing more will happen. Of course, you can do more advanced stuff here. You can check the status and then you can react to that status. For instance, if the result comes back with destination blocked, you could take actions to do something in that case. Anyway, what we do then is that once we have the result, we simply ask the unit to move along the path that we just got back. Now then, the request itself is created. For the most part, you would want to use this callback request. So it needs the callback, obviously, that we just created up here, and then it needs some information. It needs to know from where and to where. So we move from the unit's position and to the target. And then it needs some information about the unit for which this request should be used. The requested properties cover the different capabilities of the unit and its size, and then we have some Pathfinder options that govern how the Pathfinder will work. We'll see that in just a second. And then finally we'll just queue this request with the Pathfinder, and once it completes, the callback will be called and the unit will start moving. So let's just see that in action, and then we'll look at these different options afterwards. So we have the first one here, first example. It is enabled, so when we start the scene, the unit will then start moving towards the target. So let's look at these options, or the required properties for the request. Now, as you recall, there are two: requested properties and Pathfinder options. So the requested properties has to do with the unit, and this is basically encapsulated in the unit component. It's comprised of the height navigation capabilities. This is all covered in another video. Basically what it has to do with is, well, the capabilities of the unit for scaling different heights, moving up slopes and the like. And then we also have the radius of the unit and a few other things. The second thing it needs are these Pathfinder options. Now this is what was originally placed on the steer for path component itself, but now it has been moved to a separate component. So you could basically have this. This has nothing to do with the unit as such, so this could be set globally if you want. But usually you will want to have it on the unit because that allows you to do some shortcuts, as we will see in just a second. And it has these same options as it's had in the past. Nothing much has changed here. So, having covered that, let's move on to another example. This is basically just a simpler way of doing this. In example 2, we have the exact same thing we want to do. We've adjusted the callback a little bit. I'll get back to that in a second. But the request creation itself is a bit more simple. As you can see, the unit actually has a method. This is an extension method called create path request, which will create a path request for this particular unit. And as you can see, it's a bit shorter. Simply pass it the target destination and the callback to call when it is complete. Other than that, it is the same. Now, a slight modification that we've made in the callback is to inspect the result to see if the path cost is too high. If it is, it will not move and it will just debug log. Now, the path cost is a value that represents the length of the path and any cost that the path has due to costs on the cells applied by cost fields. Now, cost fields is not fully implemented yet, but there will be a separate video on that when it is. The path cost does not represent the length of the route as such, because it will be higher than the actual length in meters from the origin to the destination, but it can be used, to compare with different set values. You can just experiment to see how it is, of course, predictable in the way that basically what it is that a cell's cost is its size times 10 if it is a straight move, or its size times 14 if it is a vertical diagonal move. Sorry. But let's just see this in action. I mean, it will work exactly the same, apart from, of course, if the cost is too high, it will not actually move. So, oops, this is too far away. It's not going to move there. Let's move it a bit closer, and then see it actually move to the target. Okay, moving on. Third example. This has to do with path costs as well. So in this one, we'll just show that you have another option for your path requests, that you, instead of actually issuing the request and getting the path back, you can opt to set the type to Intel only. This will still queue it with the pathfinder and it will still find the path, but it will not actually create the path. So it will save that part of the process. So it will only give you back the cost of the path, which you can then use normally for AI purposes to determine if that is actually a path you would like to move across along, and if it is, then you can well, in this case you would have to re-request the path with a normal path request, but in some cases it might be better to, if you have lots of path requests that you need to choose between, might be smarter to take them with Intel only, and then once you have gotten the one that you want to use, then you can issue that again as a full request. So as you can see, this one doesn't move the unit at all. It will simply report the path cost. So when we execute this, we'll have the log saying as the path cost was 77 here, and down here it is, well, some more. Alright, so moving to the last example. We still have support for the iNeedPath interface, which was the original one to request a path. This was actually required if you wanted a path. You can still use this, and it is still in use by some components. It has changed a little bit because now it only requires you to implement one method, which is this down here, consume path result, and it works pretty much the same. So instead of a callback that we saw before, it will basically call back to this instead. Also, this is no longer on another thread. This will always be marshaled onto the main thread, So you are free to call Unity stuff in this method right away. Other than that, the path request, of course, it's no longer the callback path request. This is just the basic path request, and it requires one more property to be set, which is the requester that it needs to call back to, which is the initPath implementation. In this case, this is just this. So activating that will just, as before, see the unit move towards the target. That's it for path requests. See you in the next video.